Okay, so for question 9 of this paper, we have f of x equals to this expression, and we need to express f of x in partial fractions. So if we observe, we have one linear fraction, one linear expression, and one quadratic expression. So we will let f of x equals to a over 3x plus 2. And then since this is a quadratic expression, we need to write bx plus c over x squared plus 4. And we have been told that it equals to 7x plus 18 over 3x plus 2 over multiplied by x squared plus 4. Now, let's rearrange this. So if we were to multiply this entire denominator to the other side, we would have a 3x plus 2 x squared plus 4 over 3x plus 2 plus bx plus c 3x plus 2 x squared plus 4 over x squared plus 4 equals to the same thing. Let's just not write it here. Let's simplify first. So this and this cancel, and this and this cancel, and we would have a times x squared plus 4 plus bx plus c multiplied by 3x plus 2 is equal to 7x plus 18. Okay. Now, first, we need to try and find the values of a, b, and c. So what we're trying to do is that we want to make this 0 so that this entire expression becomes 0. So first, we are going to take our value for x as minus 2 over 3. Now, how do we know to take this value is that since we want this to go to 0, we will just equate 3x plus 2 to 0. And from there, we get x as minus 2 over 3. That's how we know. So if we take that, let me just write 7x plus 18 towards the other side, but we will have 7 times minus 2 over 3 plus 18 is equal to a. The square of this would be 4 over 9 plus 4, and this entire expression with bx plus c has gone to 0. So that will give us 13 wholes 1 over 3 is equal to a times 4 wholes 4 over 9. And if we simplify using a calculator very quickly, we get a is equal to 3. Now that we have that, we will try and find the values for b and c. So for x squared plus 4, we can't make this expression go to 0 because even if we put 2 or minus 2, the square will always be positive. So instead, we are going to take x as 0. So first, let's try that. And so if we take 7x will become into 0 plus 18 is equal to a times 4 plus bx will also become 0, and so we'll have c times just 2 because 3x will also become 0. So we have 18. A we already found is 3, so 3 times 4 is 12 plus 2c, and we get 2c is equal to 6, and so c is equal to 3. Now that we have found this, we need to find what the value for b is. So for that, we're going to take another simple number. So we will take x as 1 now, and so we have 7x plus 18 is equal to 3 because we already found the value of a. X squared plus 4 plus bx plus 3 and 3x plus 2. So taking x as 1, we will have 7 plus 18 is equal to 3 times 5 plus b plus 3 times 3 plus 2. So now we have 25 is equal to 15 plus b plus 3 times 5. So 5b plus 3, and we'll get 10 is equal to 5b plus 3, and 2 is equal to b plus 3, and so b is equal to minus 1. So now we have found that a is equal to 3, c is equal to 3, and b is equal to minus 1. So we can write our expression f of x is equal to 3 over 3x plus 2 plus minus x plus 3 over x squared plus 4. And that is the answer. Now, for part B of this question, we need to hence find the exact value of the integral with the limits 2 and 0. So let's write it down first. So limits 2 and 0. And since it says hence, we obviously know we have to use what we found in the last part. We have 3 over 3x plus 2 minus x plus 3 over x squared plus 4 dx. Now, to make this simpler for ourselves, let's just write it broken apart. So we are going to write it like limits 2, 0, 3 over 3x plus 2 minus limits, again, x over x squared plus 4, 2 and 0, and plus integral of 3 over x squared plus 4. So this just makes it easier for us to do it one by one. Now, the integral of this will be very simple. So we will take the 3 out and the rest will just come in ln. So ln 3x plus 2, and we have to divide by the derivative of the bracket. So that would be 3. And this just cancels. And so for this part, we have ln 3x plus 2 with the limits, 2 and 0. Now for this part, we need to use substitution. So it's actually very simple to do, but I want to explain it piece by piece over here. So we have this, and we need to use u substitution. So we will let u as x squared plus 4. So du of dx would be 2x. So dx would be, it would be 2x, du over 2x. Now, if we replace this back in the main equation, we will have x over u, and instead of dx, we will write du over 2x. So x and x will cancel here, and we will be left with 1 over 2u du. And we're going to let the limit stay for now, because in the end, we will revert back to x. So we have, let's take the half outside, and we will have 1 over u du, and so that is just half ln u with the limits 2 and 0. So let's replace u back. We took u as x squared plus 4, so we will have ln half ln x squared plus 4 with these limits. And so if we put 2 and 0 in, let's just simplify this right now. We will have ln 2 squared plus 4 would be 8, and ln 0 plus 4 is just ln 4, and so we have ln 8 over 4, because whenever you minus, you have to divide, and we will get half ln 2. So that is what we found for this part, this section right here. Now, let's also just replace the limits for this as well. Let's change the color because it's getting a little confusing. So if we put in the limits for half, there's no half here. ln 3 times 2 is 6, so plus 2 is 8, minus ln, if we put 3x will become 0, so it'll just be ln 2. That will give us ln 4. Okay, so that is for this part. Now for this third part, we need to use a rule that was given in our formula book, in our list of formulas. So let me write it down for you here. It is integral of 1 over x squared plus a squared dx is 1 over a tan inverse of x over a. So we need to make whatever we have over here look as similar to our formula here to use it. So we have x squared plus 4, so a squared is equal to 4. So in this case, a is equal to 2. So we can take our 3 out to make it simpler for us, and we will have 1 over x squared plus 2 squared dx. So that will equal to 3 over 2, because we have a 3 instead of a 1 over here. 3 over 2 tan inverse x over a, our a is 2. So now we have this. So let's simplify now. We will get 3 over 2 tan inverse of 1 minus 3 over 2 tan inverse of 0. So this entire part will become 0. You can check from a calculator. So we will have 3 over 2 tan inverse is pi over 4. So we can write it like that, minus 0, and that is just 3 pi over 8. So now we have the integral of the first part, and we found the integral of the second portion and the third portion. So let's rewrite it. So the integral of f of x dx is equal to ln 4 minus half ln 2 plus 3 pi over 8. Now you can see that ln 4 can also be written as ln 2 square, and the power will come as the coefficient, so that is just 2 ln 2. Now we could write ln 2 ln 2 minus half ln 2 plus 3 pi over 8, and 2 minus half will give us 3 over 2 ln 2 plus 3 pi over 8. So this is our most simplified version of the final answer for part B. I hope you all understood, because as you can see, this question is for 6 marks and we couldn't get it right if we did not have part A right, which is also for 5 marks. So a very simple question that can be done very well with good practice. So you can identify where you have to use your rules, your formulas, and where you have to use U substitution.